I'm Fernando, work for Percona Consulting and manage the support team. And we're going to be discussing PHP ORM libraries today. So we're going to be discussing what our ORM libraries are, discussing the two models that they're trying to bridge in some detail. I had to readjust a little bit the contents to fit into the 4 or 5 minute format, because otherwise it's going to end up running too long. And I made the decision to focus more on the theory and the design decisions behind every framework that's out there for PHP today, and also the theory behind ORMs itself, and just then took a quick glance to some of the projects out there, because I figured, I mean, it's kind of like a waste of time, because you can just go on a website and do it in a few minutes yourself. Well, I believe that this thing should provide a better value, but this hopefully it should prove to be true. Specifically, we're going to take a look at ORM patterns that are behind each of the frameworks that are available right now for PHP and for other languages. I just focus on the ones we have in PHP. Then discuss this in the context of the libraries themselves, and go over some conclusions. Throughout the talk and at the end, I'm going to try to emphasize some pitfalls that you may and probably will find while using these tools. So what is an ORM? It is a tool to isolate developers from SQL. Now, I'm a programmer myself. I work in a company that is focused on databases and mostly MySQL. But most of my life, I've mostly been a programmer, and otherwise a programmer and you know, the full IT guy to have to do all things. So I don't have any kind of aversion against programmers, and this is not intended in a negative way. It's actually usually a good thing. I mean, you need to focus on your code, and most programmers who are in object orientation don't really want to get mixed with SQL queries. So these layers in the middle can isolate that. Also, when you have a larger team and you have junior staff and senior developers, you may as well want to get some senior developers and maybe DBAs to optimize queries and have all that in just one single spot in your application, and have the junior staff to just use libraries to access that and not really be able to execute things that could go the wrong way. And they bridge the gap between two different models, and that's what we're going to focus for the first part of this talk. We have the object-oriented model and the relational model. But before we get there, I want to go through a couple of concepts. A model is something that should help you see things simpler, to make your life easy, but should still be powerful enough to reflect reality. And we'll get back to this when we see that sometimes the failures and the pitfalls that you will encounter while using ORMs are just a consequence of not understanding the model behind them, not really, the blame of the library itself in its case. So some things are designed to do one thing, and it's like if you use a hammer to turn a screw. It's not designed to that, so if you get bad results, it's not the hammer's fault. And a mapper, it's just an object that communication between two independent objects, and they can be subsystems. So in this case, it can be a full application and a database server. This definition of mapper is from Fowler, which is a great book if you're interested in development. And basically, it's the book for patterns, besides the blue book, but this one I think has more content. And just about, if you take a look at the open source project out there, most of them, like if you go to Solar, they just borrow the diagrams from Fowler's webpage when they use this. They're not the DB class, If you have a class that's most like an utility class where you will be able to execute queries, manage connections. You just tell me anytime you have questions, by the way. That's not an ORM. That's a place where you can a model when you get your code together clean to access the database. ORMs actually use this, and this has a separate set of problems that are usually easier to solve, like configuration management, different levels of staging, production, development, but still, it's a different thing. It's just a way to access, but in this case, a relational database, it could be, an XML file, it could be another server, anything. What they do is they map the object-oriented domain model to a relational model. Okay? So when you have, say, Drupal, you have a project that in this case is developed and designed using the object-oriented model, at one given point in time, if it is a useful project, you will want to persist some of your data and save state for next run, and it is very common to do that through relational databases and MySQL in this case. And you can either hard code queries and scatter this all throughout your code, or you can try to do that in one point. And one of the ways to do that is through these libraries. And they can also help you dealing with the changing domains, both the object-oriented domain and the relational domain. What I mean with this is that you could probably plan that maybe your database is going to be changing, you're going to be altering the schema over the time, because you know that your business requirement will do that. You may get new fields that you will need to store in a customer record, and you want to try to have the least possible impact in your application layer for that. So if you just have a mapping layer that could be kind of like a middleware in this case, that isolates both worlds, both of them can pretty much evolve in a good independent way. There's a lot of work to do in the middle, of course. Now, it's also that developers want to persist objects, and most don't really care how it's done. So we get back to this, I think, in the next slide. It's all like abstraction. I mean, you just want to push the save method, and you don't care how it's done. And actually, that's pretty much the same in databases. When you issue a query, and you're telling the server what you want, but you don't tell it how it's supposed to do it. So it's not that different. We use these sort of abstractions all the time to make it a lot simpler. And also, that's the thing that is true with many people, is the developers tend to have SQL aversion. So they don't want to, it's obviously old, and they don't want to write this code. So if you propose an object-oriented interface to it, and we will see in some examples that some libraries have methods that basically look like just, you don't really leave your domain anytime, although they do look a lot like SQL if you are a DBA or if you do a lot of queries. Yeah, it makes the life simpler. So to compare both models, this is going to be quickly and all depending on what you guys have in experience. Just stop me or tell me to get faster if you don't care. So in object-oriented model, everything is an object. That was not really the case in PHP, but we can just assume there is. And these are units of data that collaborate to get things done. You get abstraction, which is what we do in daily life, not just in programming, to deal with the complexity of the world. We try to find common patterns and put names of things and labels so that we can refer to them. So if this chair, I know that this chair is a chair and the one outside too, though they're different. So in object orientation, what we do, we use classes to refer to things in real life. So we will have a customer class, or well, I'm really so 1992, or you could have like a tweet class or something like that to get it more up to date. But the point is that you have an entity that reflects something that exists for real in your world, and you want to model it. And that also relates with encapsulation, which is like you don't really know the details of how it's done. And SQL, like I said, is a form of encapsulation. You don't really know how it's done, actually. And most of the time, you don't care. You also have polymorphism, which is that several classes can be used interchangeably if they are related. That you could have a customer that maybe it's also a person, and could be an employee in another context. And so when you have this, you have to use inheritance and just say, okay, we have some common behavior here, some common data, let's model this thing so that we can reuse this code. And I put inheritance in italics here because this is one of the things that gives us more problems when we try to map these structures into a relational database. Actually, there is no straightforward way to do this, and any way that you choose has pros and cons. Now, modularity is just organizing things for functional or semantical nearity, so it's not really that good to go. Whereas the relational model, everything is a relation instead of an object. Though that's not really true either in any commercial or open source engine out there. In this case, relations mean to the table definition. This is a formal concept, but I think it is good to get the grasp of it, because the people who write ORMs, they actually need to grasp this concept to do the right thing. And if you're going to choose a tool, or if you're going to deploy your own for a next project, you should know the foundations behind it to make the right decision. But basically what we do, we just say, okay, we have a table. In the case of SQL, we have a table, okay, the table definition, the create table, that's the relation. It's the relation between, you know, the column names and the column contents. You have relational variables with actually the table or rather the snapshot of the table at any given point in time. And you have rows and columns with just a relational name. And the good thing about this is it's based on first order predicate logic, so it has a solid math foundation behind it. And it's not the same with, you know, object-oriented design. Can be very good, but it can't say the same thing about it. So relations are just a heading and another set of two. It's actually an extrapolation of the binary math relation. These are n-ary relations. Now with concrete examples, in object orientation we'll have a class, say customer. This defines a template, which I quoted because it may not be the happiest choice if you can say it from C++. It does have a meaning there, but I couldn't find any other way to use this. And so all customers are going to share this behavior. And every customer object is going to be an instance of this class. So they share the same behavior, maybe some common data, and maybe some private data for each instance. They can probably store, but in an unspecified way. I mean, if you take a look at the blueprints and all things in object orientation, there is no specification about how to store things. You just care about your relationships, basically in memory, and then you have to go through all sorts of patterns, like what we're going to go now, to when you actually need to save that somewhere, be it a database or even just a file. And in this case, an object instance, what it means is, well, I am customer X with H, N, B to C. Whereas in the relational model, you will have a table called customer. Traditionally, it's plural in relational in databases and singular in object orientation. This defines the predicate for a customer, which is just the table header. Okay. And the customer has an ID, name, so that's the table definition. And so these customers, they share the predicate. And what a row means, it's a certain truth fact. It means this predicate is true for these following values. Now, in everyday life, what we say is, okay, this table has a row with this ID. But it's important to know that actually behind that, we're talking about these sets. Data is also stored in an unspecified way. You just, you issue an SQL statement, either to store it or retrieve it, and you don't know how it's done. And usually you don't really care unless you grow really large, like I put there, or things go bad. And that's when you start to break encapsulation, and different engines, like MySQL, you can say force an index. So you begin to try to, through this supposedly functional and declarative language, try to affect how the engine behind it implements this thing that you ask it to do. Okay. So all the time, even though we try to keep things separated in tiers and very nicely, I'll go back to the definition of model. It should make your life easier by being simple, but should reflect reality. Once you stop reflecting it, it doesn't matter and it breaks down. So sometimes you gotta mix in both things. So when you try to map your object-oriented structure to a database, you have what you may have heard is object-relational impedance mismatch. It is taken from the electrical term impedance matching, which is the opposite. It means that you really can't, it's hard to get both things to get the same signal level. So it's expressed the difficulty to map an object-oriented domain to a relational database. And you have basically two types of problems. One are data type problems, which are the easiest to solve, but are still potentially very hard and can give you a lot of trouble. Here what I mean is that, usually if you use tools that generate code stubs, you will get, say, you have a string in your code, you end up having a var 255 characters. Okay? And if you don't change it, that's the default, and that's the way it's going to be. And if you just have a small application, that's not going to do any harm, but if you grow large, that's definitely not the best way to go. And it's good if you find out when you start, and if you then have to begin doing alter tables on large data sets to fix something that should have been caught at first. So this is a simple problem to solve and to catch, but it can have serious impact on the long term. And the other is design mapping problems, and this is really the key of the thing. It's that both the models, object orientation and the relational, are not isomorphic. So usually you will have a structure in your database, and it's going to be very hard to reflect the structure with your objects and vice versa, unless your structures are really simple. This design mapping problems, we can basically summarize. You have interfaces. Interfaces are just define a contract. So you say, well, I have this set of classes like a cache. That's all. You can have You can do caching through memcached, or maybe file system is a small thing, or anything. And as a programmer, you don't really care how it's done. You just want, to check if something is there, or get it. So it's a good thing to define an interface of what a cache should do, the service that it should provide, and then you have each individual implementation behind it. And when you apply this to entities that you want to store, like say again, back to the example, you have a person, and the person can be a customer, or it can also be an employee, or it can be a partner. You have this weird thing that when you want to store it or retrieve it, you will be asking the layer to, okay, so give me person with ID, and you don't have a table for persons. So it's kind of like mapping hierarchy. You end up having either one large table for all your entities, or you end up having to doing joins behind the scenes here, so to speak. Excuse me, I'm not a native English speaker, so I may get stopped sometimes. To solve this, either the library does it or you do it, but the fact is that you're going to be asking for something that doesn't exist in the database, and you still need to recreate it either from the tables that it's spread of, or just get it from one big thing. And we're going to see the problems about the one big thing later on when we deal with hierarchy. So in inheritance, you can have single table mapping. You put all your classes in one table. This means that this table needs to have columns to reflect all the attributes of your objects. So it can be potentially huge depending on the size of your hierarchy. It also means that depending on how your sets intersect in terms of this inheritance, you can have potentially a lot of null columns there. Because for a lot of rows, many columns won't make any sense. Say you have a person that is not a customer, so a customer name, customer ID, or whatever, doesn't make any sense there, and you're going to have to reflect that somewhere. So either you're using nulls, which depending on type queries that you're going to run in the future, will have an impact in performance, or you will have to be doing all sorts of things that also break the whole nice relational thing, like choosing a value that is within your domain but is non-valid, like say, okay, -1 is not a valid customer number, things like that. So all that has impact in your logic. Your programs will be more complex by doing this. Somewhere, either your real application, or the layer in the middle, or the database suffers because you don't do this and you just say, okay, deal with the nulls and that's it. You can have one table per class, and then one per concrete class. And the difference here is just that, depending on how your hierarchy is, one of those could have a lot of tables. But with the other, the major thing is that since you have, say, one table for customers, one for partners, etc., you will have to do a join when you're going to grab the whole aggregated view of this. Now, this is not necessarily a bad thing, because databases are supposed to be good at doing joins. That's what they do. But, things could go wrong if your size is wrong. The other option, the one single table, has also many drawbacks, because, you could end up reaching limits of, if you have to do tables counts, if you have to do a lot of things that involve going through a lot of queries, it's best if you do it over joining the smaller tables that you have to just go through one huge thing. So in this case, again, what you need to do is to know up front how your data is going to be ordered. Try to know more about your business problem and make the best decision based on that. So what I'm trying to get at, if nobody can give you an answer and say, one or other is best. Each can be good depending on your problem. And you can do hybrid mapping. So depending, in this case, if you have a really complex hierarchy of inheritance, you can just say, okay, these classes will have a lot of overlapping attributes. I'm going to map to one table, because it makes sense. I'm not going to get a lot of nulls or anything. And these are like satellite classes that have less members and don't have so collision, I'm going to put two individual tables. But that also adds complexity to the layer. And we will get back to this when we get the tour of the libraries. So here are the patterns that, if you take a look around, all of the libraries for PHP definitely, and if you go for Java too, are based on. So we have table data gateway, row data gateway, active record, which should be very popular now, but because of Ruby on Rails, and data mapper. And method mapping is used in most of the case. So before we go on to describe them, I got this beautiful, for me at least, definition. This is by Christopher Alexander, is an architect, and I think this is from 1977 in a book about patterns in architecture. And he's saying, each pattern describes a problem, and I put that in bold, which occurs over and over again in our environment. and then describe the core of the solution, just the core of it, okay, to that problem in such a way that you can use this solution over 1,000,000 times without ever doing it the same way twice. So I could involve some things here. First, the problem. In order to make a good use of a pattern, any of it, you need to understand the problem it was designed to solve. So don't just go use active record because it's the new cool thing. Go learn, okay, so what was the problem that the people who designed this pattern found? Do you have the same problem? Yes? Okay, it's for you. Do you have a different problem? Okay, just keep looking, or maybe you have to use active record with a different thing. So in the case, active record is great if you have a very good, if your models are almost isomorphic, if you are trying to map tables directly and you have not very complex relationships, and also if you want to keep domain data in your objects, because basically you will have an instance for every table, and then you don't really have to care about how you fetch the data. Well, it should be generated. You have to write it or generate it, but usually it's involving code generation. Now, if you go to more complex relationships, you will see, if you take a look around, say, Ruby on Rails, PHP, the solutions that we get proposed to deal with complex foreign key things and tables in the middle, it's that, no, they're not nice. You end up having to do things by hand or mixing a lot, and you break the thing that you're using. So this thing is designed to solve this problem. Okay, use it for that. So table data gateway, it uses stateless. What I mean with this, that doesn't really care about the object that you're storing. It's more, in this case, more like an utility library where you put all your SQL related functions. It's just that this is related to one particular table. You will have one of these for every table in your system. This is why it's a good candidate for code generation, because it can get pretty boring to do this by hand, and you can also get mistakes. And also, if you're on the development stage and you keep changing column names and such, it's not a nice place to be. You have to be constantly changing things that make you feel like your brain shrinks, because you're just basically writing get, sets, and all sorts of things. So you can generate this thing. And it's useful for a direct or simple mapping between your objects and your database. Again, if you're just mapping, object to table, I just want to store it and get it back. I use the database like a persistent layer, but that's it. This is great, great. And it can be used in combination with data mapper, which we'll see later now. Here's a diagram. And in this case, the company would be your entity, the thing of the real world that you want to store. So you just get one extra class. It's the gateway. And this will be the class. You will have one instance of this for every table in your model that will deal with the SQL for this. And as you can see, the functions are very simple. You just have finders, method to insert, and to update. So what is missing there, for example, is how to do, how to join Granite table, how to do sort of things. And the fact is that, well, if it is just like a foreign key join where you just have one table that has an attribute for another table and that's it, you can usually do it. And actually, we'll see that some of the libraries do it. But if you have an intermediate table to reflect that join, you will have to use table data gateway to refer to that table explicitly, or you will have to hide this somehow, because it doesn't know about this whole relationship. It wasn't designed to do that. Okay, if you got Zend table is basically an implementation of this. I don't know if anyone uses Zend Framework, but it is this. And you see that the nice thing about it, in the latest versions, you don't even have to define the table, because you just create it with the name, and if you follow some conventions, it will use some queries that we'll also see later that could potentially be bad, like show create table for that table, so it figures how to structure, and it will populate an object for you, and so you just automatically can do insert and select from that table with just doing basically 2 lines. So if you just want, again, use the database as a persistent layer, this could be pretty good. Propel uses this in combination with raw data gateway, we'll see just right after now. And Solar uses, it's really complex, uses a mix of this two with data mapper. Data mapper, we'll see more ahead, that is basically just, you roll your own framework. That's basically it. Raw data gateway, it may look similar at first. We'll have another diagram to clarify. The objects map record in the database, but in this case you will have one instance for every row. So this is more like active record, and actually it is active record with no domain logic. If you have used PHP, you will see in active record, you have some domain information and the methods to access the database. The raw data gateway just cares about how to store things. It doesn't have any knowledge of its own. So actually, the only difference is that if you don't have a real complex domain thing, this is the good way to go. Otherwise, active record is the way to go. And this can be used in combination with other patterns. Now, the difference between the two gateways basically is if you are going to be accessing your tables this can be good for iterators, you know, through other things. For transaction script is another pattern in which you access the database through things called transactions, but you know, it's not a happy name, but the pattern is called that way because it's not a database transaction. It is an application level transaction, and it's just, you know, a set of things that you want to do as a unit of work. And in that case, the difference is that if you see table data gateway deals with the whole table, so when you do a query, you will get back a result set. And there is no easy way to hide that from the application behind. So you can either, you know, change that to an array or whatever, but still, whomever is behind that will really know that you're getting a table. In this case, as I said, you can use it with an iterator, and so you can use both in combination, and the person behind doesn't really know where this is going. It's just, you know, giving the next one with the next one, and that's all. So if you really need to isolate completely, but still have a simple structure, your code from your database, raw data gateway is a good help. Otherwise, table data gateway is great, but remember that you will be getting back a full result set, and you will have to deal with it somehow. So here it is, and if you notice, basically the change is that we still have the gateway here, and we've created a new class. This is the finder, and the only reason is that since we will have an object for every row, an instance, sorry, for every row in the database, it doesn't make any sense to repeat the code for things that are common for all the rows. So you have the finder, which is typically a static table, and you have one of those for each table. And then you have the gateway, which is the one that, yes, it is. So one instance of company gateway reflects one row in the company table. And this is what allows you to get more abstraction to the layers behind. Active record is basically the same thing, just that it has some domain logic we'll see right now. You just merge two things in the model. So it can also be like it's an object-oriented domain model that is isomorphic to a relational model. If you're using an active record the right way, what it means is that the way your data is structured in memory is pretty much the way you can reflect it in a database. So that's a good way. And it's a good candidate for code generation. You know? And Ruby on Rails and PHP, they do that. So you see, we just don't use the gateway at all. What we did, we got the methods to access the database back into the domain class. This is what we mean. If you have a complex domain, you may want to just put these methods in the domain class and have this instance over here. It simplifies the design, but it's a good decision only if your domain is complex. So this example may not be the happiest one because it's the same class as the previous slide. But if this would have been a complex class, this is the best way to go. And it's also a one-on-one relationship with rows. So an active record instance is associated with one row in your database. So it's also a good pattern to hide the fact that you're getting results to people behind this. So you're not going to get results behind this. Doctrine uses this, along with others. And Solar2 and Coordinator, besides PHP, is also active record in the PHP world. So data mapper, like I said, is basically a layer of mappers, and if you remember from one of the first slides, there is just something that helps communicate two different things. And it communicates objects in the database. So this is useful when you really have two different models. So your object model is too complex. Okay, you have long hierarchies of inheritance, and you have complex relationships. So in this case, what you end up doing is you pretty much write custom tailored mappers for every part of your architecture. So it's also useful when, you know, models can evolve independently. We mentioned this before, the ORMs in general can be good for this, but not all. Active record is not going to protect you from, you know, you creating new relationships because it's maybe not going to be able to deal with it. Though on the other hand, any of those with code generation and reflection abilities are going to surely support the fact that you add new columns to a database, and your objects are just going to be happily receiving these new attributes, just, you know, automatically. We will get back to this and see that there's a pitfall here that could be in terms of performance with the type of queries that you execute to get this whole introspection thing. So, and it's also useful, like I say, when you have inheritance on foreign key. You have a couple of patterns there, the inheritance mappers. If you go to follow, for example, this is just, you know, a formalization of the, okay, you can map this to one single table, you can map this to one table per class, it's just that. And foreign key mapping is just a way to deal with foreign keys in these things, but it doesn't deal still with the fact that you could have a relation table. So this is also foreign keys when you just have two tables involved. If you have 3 tables or more tables, you have to do that by hand. So it's just a sample model, actually. It could have been anything, just to give you an idea that you have your domain there, and you have, for instance, I chose to have an identifiable object, like an interface there, to say, okay, anything that I'm going to save should have an ID, should be identifiable. That's the only thing that we're going to ask if you need to be stored. And on the other hand, you will define an abstract mapper. This is the thing that all your mappers are going to inherit, because maybe, you know, something like inserts and updates, those are good candidates for code generation, and an insert statement, regardless of your structure, is usually simple. Now, usually, if you have complex relationships, you will have to dig down, like say, you're saving in this case, an order and all of the lines of this order. So it's really easy in an object to have this in memory. And now when you want to do the save method, you need to reflect that into the relationships in the database. So you cannot just have one single insert statement. And in this case, what you do is that when you have an abstract class, you inherit this class and you override this method to get a proper insert that will take care of that, hopefully within a transaction, so that you get all nothing and on nothing. So the idea is that you put the thing that most of the simple cases would use in an abstract class, and then you basically implement one class, not just for every class in your domain, but actually for every class and or every relationship that you will need to handle. Okay? And metadata mapping is used across all the others, and this is just a formalization also of the thing that, okay, when we're storing objects in the database, we need to know, okay, this class, what is the table that goes with it? Most libraries are right now, they're using, I believe, but I'm not an expert on Ruby, but I think that they are the guys that brought this up, the convention over configuration. So if you don't specify anything, I'll go along with what I think should be. And they just map the class name to the table name that's the same. But if you want to change it, the library, or if you don't use an ORM, still, your code will need to have a way to map this to know, okay, this object goes to this table. And this is the metadata mapping. You will have a pattern, let me go back and then I'll go back again. That is basically an aggregation. You will have a data map when you say, okay, so this class goes to this table, and this aggregates the rows that say, okay, so this attribute goes to this field. This is a simplification. It can also obviously be more complex because you surely not want to store all your fields. You will have like calculated fields, and so you need to know. You have very simple, like the primary key, and you will see an example of Propel does that. You don't want to have the ORM insert that, so you just need to tell them that, okay, this should not go in the database when we do an insert. So you will need more things. But the basic information is just this mapping, and this is the primary key. And you have two ways to do it. You can generate the code, so you can do things like Propel has this. Cake does too in this kind of things. You bake the things, and in Propel you have Propel generator. You have a generation stage, and then you have a runtime stage when you're just running your application with the runtime environment for the ORM library. The good thing about this is it's usually way faster because you only go through the stage of doing reflection, figure out class name, class attributes, and also figuring out the table, show, create table, and all that once. The downside is that you change your build and deploy procedures, and whenever you change your schema, you will have to redeploy. That may sound obvious that you always have to do it, but if you use the automatic ways, you'll see that some changes, like a column change in its name, it's handled automatically. So reflection is that thing. Is that you don't tell how to do it, and what it does, you make uses of the language. PHP has it. It was improved in 5.3. And Java definitely has it, that you okay, I have this class, give me a class object for this class, and I want to know what is its name, what methods does it have, what attributes does it have. So with that information, you can decide what needs to be stored in the database. And on the database side, in MySQL, basically what they do is they do a show create table for the table name, and they get the whole thing of the column definition, length, and all that. It has an impact on performance, like I said, also because I will get back to this at the end, but you will need to watch out for the signal-to-noise ratio in ORMs when you're using that in your queries. You will realize in the PHP world, it's not so bad. If anyone does Java things, for some reason the libraries there are a bit more verbose, and it's also a thing of the driver too. But you get a lot of queries that really have nothing to do with what you're trying to do with your database, like show create table, set auto commit, things that you don't really want to do all the time, and you don't need to either. So this is what I mean about signal-to-noise ratio. If you have a reasonably low or even normal load, this won't impact you, but it's a good way to cut corners and get ready for when things can grow, because you don't have to do it all the time. So, these patterns. The first, table data gateway, table row gateway, and active record, are good if you have a good match between your models. Okay, so if your object-oriented model is not too complex, or on the other hand, it could be complex, but you just want to store certain objects. Or you don't care about the extra cost of knowing that if you have a relationship, you will have to address that relation in the table directly, meaning that you will probably lose performance, but you also will lose abstraction, which is supposedly the reason why you began using an ORM. I don't know if that's clear. What I mean is that if you have to do a join, and we will see concrete examples, you basically won't be able to do it unless you do it by hand. So that kind of is the point. And if you have a complex domain model, the data mapper is the way to go. And this chart basically shows with some of the frameworks we've had for PHP, and there are way many more, but I just chose what I think are the most widely used ones, the patterns that they use. And the good thing about it is that towards the left, the right, sorry, is you will get the ones that can deal with more complex situations. Okay, so Doctrine and Solar, if you see the table, are the ones that you should consider using if you have a complex object domain, but if you really want to have good support for mapping joins and relationship, hierarchy. Whereas on the other side, Propel, Zend, the others, they have good if you just want to have, like I said, you're using the database as a persistent layer, but you don't really care about the fact that all the things that databases can do besides store data. That may or may not be a good choice. You may not even need a database in that case, or at least a relational database. But still, if you want to do it, this is the way to go. Propel. Propel is table data gateway and row data gateway. Like I said many times, it's straightforward table mapping, and you have a very basic example there. You just create a new company, set the properties, and save, and it's done. This is one-to-one, so they will go to a table called company. There is no mapping support for multiple cardinality relationships. So either you reference the table directly, or you do that in your stock classes. The stock classes thing is so that you can, coexist the fact that you generate a lot of code with the fact that you, over time, you will begin to adding your own code too. So that's what you will realize. And say, for instance, I think in Propel it is about 5 classes for every table that you need to manage. And that is just to give you need some abstract classes and some concrete classes, so you have a place where you can put your changes, and it doesn't change if you regenerate. But still, it's a lot of code. That's why usually projects that use libraries tend to be large in number of classes, which doesn't have to be a bad thing. It's just what it is. This is from the user documentation, this example. If you're going to get all the readers for every book, what it will do in 2 ways. It will decompose the join, basically. It will do a select star from book, and then for every book ID that it gets, it will do select stars from book and do this join, okay? But you will get, this is n queries depending on the amount of entries that the rows that the book table has. The natural way to do it would be just go with a straight join. And you can do this, but you have to change, modify, use style classes. So what I was saying, if you need to do this a lot, it can just question the fact that why you're using this at all. Yeah.
So for the row instead of gateway, sorry, the row gateway and the active record, how does it work if I have, let's say I have a customer who lives, well, let's make it simple. Let's give the user just one address, right? The customer just one address. So in the database, I would have like customer with a foreign key to address. So how do I, if I have hold of the customer objects in PHP code, what would I do to get the address?
For example, Propel, in this case, uses the pattern that we have mentioned before, just quick, getting back here. Foreign key mapping, it uses that pattern too. So, in Propel, what you can do is if in this sort of relationship, where you don't have an intermediate table, you can just say, okay, customer and get address, and it will handle that for you.
Okay, so with the generation, with the model generation, we will already have generated methods to actually get the address object out of my customer object.
Yeah, because when you do the Propel is based in the generator and the runtime. So when you do the generator, you get all the classes needed to access, in this case, the customer table. And in this stage, when you run it, it will know if assuming that everything is sane and you run it when the model in the database reflects this relationship, it will know about this and it will handle it. But you have to specify this. I mean, it's not automatically. You have to specify this with the foreign key entry in an XML file. Propel does is configured through XML, which I have a problem with, but some people don't like. And you just need to put, okay, this is a foreign key. If you take a look at the configuration, it's pretty much like straightforward telling you, okay, whenever I ask you for this property, I will actually want you to go and look at this table and get it from here. But it does it for you. It is, and from the source code perspective, once you have configured it and get it running, it's way easy and very nice to look at it because it's just a method, and actually you can these things you can change them. So, like I said, you get the customer, get the address, or customers. If there are more, you can just get that. You can also save it through that too, and it will handle it. Yes. But it won't do it for many-to-many relationships.
Okay.
So it does support single-table inheritance mapping. So this is not because Propel, but because of single-table inheritance mapping, that the table must have all columns needed by the classes. Oh. I'll try to speed up because it's almost time. You can log the queries that you issue in, which is a nice thing if you ever work with ORMs. Sometimes the thing is that it's good that it also lets you in the database, but at a given point when things go wrong, you want to know the actual query that ends up there. And of course, you can enable parallel logging on the database level, but sometimes as a developer, you may not have access to it. So it is good if you can do it on your side. And it has a criteria class to simplify SQL, which was what I was meaning. If personally, I think just issuing this select is pretty straightforward and simple, but maybe this is just an example. But you can create the criteria, add the fact that, okay, I want to get it because the name is Percona, and now give me the list of companies that match that criteria. Doctrine, active record, data mapping, and metadata mapping. You can create a model from the database, so Doctrine supports reverse engineering in this case, or you just use YAML to specify it. And it has pretty much inspired by Hibernate, a Doctrine query language, which is, sort of like showing how to do SQL. But if you look at it, it pretty much looks like it. The nice thing that it has is this thing in which you can keep concatenating method invocations. So you do the create, through that you import the from, and from that the left join. And if you have an arbitrary complex query, you can just keep adding invocation to the method. So there actually, it looks pretty nice in your code. And that what it returns is a query. I mean, up until this is not executing anything. The Doctrine query create returns a string object. That's what I mean. So it is basically a nice interface for you to write complex things and get back an SQL string. And a side effect of this is that you can print out this thing and know what it's going to send out to the database. Fast here. Zend, stable data gateway, so it is excellent for direct mapping. Okay. And you can see that, like I was saying with table data gateway, you cannot really hide the fact that you're handling result sets. In this case, you cannot really hide also the fact that you have columns behind it. Because when you insert, you actually have to pass a data array that is obviously a list of columns after values. So there is not much hiding here. And This is
basically it's not really object-oriented. You just get a very crude
Yeah.
data access.
Yeah.
Okay.
Yeah, that's it. And Zend by default uses show query tables to know about your table structure and that, but you can cache them, so it's not that bad from that point of view. So now, let's get to the things that I could think could be problems here. It's back to impedance mismatch. So what it means is, again, you need to realize the complexity of your model and then choose the proper patterns first and see which libraries implement this, so that you make sure that you're using a solution to your problem and not just a solution to another problem, which I think is what we end up having. A lot of time people say, you know, this case, X ORM is horrible, but the fact that you're using it the wrong way, okay? Choose the framework, the right model pattern for your domain. Beware of the default data types. If you use scaffolding, if you generate a lot of things, which is great when you want to get started fast, usually it's not going to be the best SQL that you will get, especially in data types. And data types are not an obvious performance problem at first, especially when you're just in development stage and you may have like what, 150, 10 rows because you just install it manually, and you suddenly go to production and deploy it and then it hits you. Beware of subjective advice. This is, you know, I don't want to put the name because I don't remember, but one of the products that I overviewed had this specifically on their manual page. This said, oh, actually it's Propel because they decoupled the join. A join wouldn't really be the best choice here. It says so in the manual. You can go and read it online. They say that. I don't think that's true. I think that, you know, joins and also decomposed joins are both a good thing within the context. Okay? So actually, who knows when it's good to decompose a join? Can you give me an example?
Well, if the main thing is, you know, is big, but the smaller set that you're joining to would be small and cacheable, then I would have no problem with decomposing it, because, you know, it would be very fast once you have cached, you know, the smaller set to retrieve it. But it would be a better idea if both sets are, you know, large and don't intersect much. If there's like for every specific object in the large set, you know, a set of objects in the other, and there's no overlap. You know.
And also sometimes, and my colleague Ryan here can correct me, but when you have certain complex joins of very large data sets, this is the MySQL case also particular, you might end up doing so much processing on the server side that it may just pay off to do the join on the application level. Because it's just cheaper for MySQL to do these more simple queries, and you join this, which is kind of like, you know, since we are in the, I didn't use any buzzword because I'm old skills, but with the NoSQL crowd, we use this to their favor. You end up losing the good thing about having a database. But you actually, you know, since at least you've been interested in the question, what you could usually can go have this book.
I have it already.
You have it already? Okay. But anybody else? Do you want the book?
I got that.
You want it? Okay, come again. But you can get another two if you ask me a good question after the show. So what I mean is that if you go read the manual, this is in the manual, you know, take it with a grain of salt. They're saying there, and what I'm trying to say, and this phrase could be true, it could be false, depending, again, if you have a huge table and you have a MySQL database server, and maybe even depending on the version, yeah, maybe a join is the worst thing to do, and you have to decouple the join. But if you're starting a project, it's like starting a project by sharding. That's not the first thing that I would do. I mean, I would just start the normal way and consider alternatives if I really need to. So watch out for documentation, because they might do things, some weird things. What I mean is sometimes implementation will lock something, and instead of saying, okay, we don't support this, they say, well, you don't really need to do this. Watch out with the single innovation query, and if you want, you can talk after the talk, so I can just...
Okay.
And again, you know, decompose join, inheritance mapping, you know, all the sort of things that are basically code generated. Watch out for that, and you should be good to go. So now, since they're apparently running me out of here, if we want to talk, I'm going to be over the Percona booth at the Expo hall. So if you're going to go over there, we can keep talking, and just any question you have, we can do there. Thanks a lot for coming.